Several generations of phage discoverers, educators, students, former students, many of whom have now moved on to professional roles. And we're here to thank you and celebrate with you for the years you've participated with us in this program and all that you've done to inspire your students and give them all kinds of opportunities that they wouldn't have had without you. So let's just thank the teachers. Yeah. I still remember my high school biology teacher fondly, so I'm grateful for all the teachers I get to work with. We have a special welcome for you guys. And some of you will know who this is, and those of you who don't, Dr. Graham Hatfull.
Good afternoon and welcome to the 2024 Phages Symposium. My name is Graham Hatfull. I'm a professor of biological sciences here at the University of Pittsburgh and a long-time phage biologist. What a wonderful occasion for you to come together and talk about the fabulous work that you've been doing with your students in phage discovery and genomics. A really marvelous contribution of the thousands of students that you've engaged over many years, contributing to new phages that have been isolated and characterized and submitted to the public databases and contributing to this overall project and goal to try to understand phage diversity and viral diversity more broadly, and to hope to put those phages into good use. We've learned a lot over the years, collectively, with our students and teachers and instructors. Our collection has grown to over 25,000 individual phages with 4,500 sequenced genomes, including all of those that you and your students have contributed. And the good news is that even though that is an amazing collection and an enormous amount of data, we clearly have a lot to learn. The more we look at phages and consider their genomes, we realize how much we don't know about them, how they grow, how they propagate, how the host range is determined, what most of the genes do. So we certainly have our work cut out to try to understand what all of these data mean. But clearly we're not done either with a vast and dynamic and very old collection of phages in the biosphere. There's clearly much to learn, and I'm delighted that you and us continue to be actively engaged in the discovery of new phages, learning about them, dissecting and analyzing their genomes, and I hope putting them to good use. Only recently have we really become interested in investigating the therapeutic potential of the phages, especially those that infect the mycobacterium pathogens. And I'm pleased to say that I think that effort is going quite well, with a number of favorable outcomes of individual patient cases where we've been able to identify phages and to administer them therapeutically. So the future is very bright. We hope to learn more about the basic biology of the phages as well as their therapeutic potential. And I hope you enjoy discussing all aspects of these phages during this symposium. And I hope to meet you all some point in the future and exchange more stories about the bacteriophages that we know and love. So enjoy the symposium, and good luck, and bye-bye.
And so for those of you who aren't familiar, I wanted to make sure we talk about what is phages. And first of all, it is a team effort, right? This is a partnership, and And Chris Doyle isn't here at the moment. I heard he's going to make an appearance this weekend. He's been in each and every one of your classrooms for years, tens of thousands of miles, discovering phages, bringing all the supplies to you over those years. So we're so happy. Raylyn, my partner here in crime, program director, project manager, everything that she needs to do to interface with us, the teachers, the schools, Montana Tech, and CFWEP. That's Raylyn, and you all know how amazing she is. And Chris Pavlovich isn't here till a few hours from now, but Dr. Pavlovich just defended her PhD, so we're really excited. And she's really brought a new flavor and a new excitement for our evaluation. She's so creative in the means that she uses to see how effective this program is. And all of us wouldn't be here without Tammy. So Tammy, let's... She takes care of everything that I have no idea how to do, right? And her expertise in everything from budget to logistics and planning, project management, we're just super grateful for all that she did to make this event and all of our events and our grants run. So thank you, Tammy. We're just so excited for this entire show here. Those of you who don't know what is Phages with all capitals, a 5-year teacher professional development project, including genuine microbiology research. This is funded by the National Institutes of Health Science Education Partnership Award. And our acronym, which we came up with, Phages helping acquire genuine experiences in science. And this isn't flippant. Your students were doing genuine discovery biology in their classrooms. Right? They're doing experimental science, citizen science, and contributing to the body of knowledge, as you just heard Dr. Hatfull say. That's where those phages come from. Your students, right? And those 25,000 phages that they have there offer them basic science and medical bioscience opportunities. So someday one of the phages from these teachers' classrooms sitting here is going to save a patient's life, and that's amazing, right? Really amazing. Okay, what were our goals? This is what we wrote. This is what we stated and claimed. Equip teachers with the knowledge, skills, and dispositions to provide high-quality, phage-based research opportunities for students. Establish a sustainable pipeline for students into the sciences, particularly the biomedical sciences. Create self-sustaining satellite labs in your schools, right, to ensure that students in underserved areas, rural areas, areas far from a college campus, right, have access to research opportunities. And I don't just want to read the slides to you, but we had a number of specific aims for the teachers. And the bottom, retain teachers in long-term professional development, right? And compare our outcomes, right? We are doing evaluation to see, do we make a difference? You know, there were surveys, there were interviews. Every summer, these teachers came together for a professional development workshop where we did hands-on biology in the lab, practicing the phage discovery skills, but also visiting electron microscopes, right? There's all sorts of, and discussions of pedagogy. The best part was the teachers fed into each other's knowledge and skill sets, right? And so, and they informed my knowledge and skill sets along with the scientific communities because they're experts at what they do, right? And this just gives them another piece of expertise that they can apply with their students. We had aims for students, relevant, meaningful classroom research experiences. And one of the highlights is that we had summer students, which we called the pipeline, summer pipeline, and we worked with Montana State University's IMBRE folks so that students who had participated in these classroom phage discovery visits could apply for 6-week summer internships at Montana Tech, or for rising college students, also 5 weeks at Bozeman, or for students who are already in college 10-week programs. And we have a number of these students in our audience today, both that worked at Montana Tech and Montana State University. So that was the big capital P phages. But we have the little p phages. There are a couple non-scientists in the room. Viruses that kill bacteria, right? And they kind of look like this. This is Tinger phage. Robert Lester worked on Tinger phage and Peter Lund this summer. It's been renamed Toedinger because the name Tinger was rejected by Pitt. But here they are infecting bacteria, right? And so this is the idea of these little creatures are the most numerous entities in the biosphere, but they can be discovered with simple techniques. They can tell us a lot about the world. How did it get to be that way? But students from even elementary school ages, simple techniques can discover phages. And all you really need are some petri dishes and basic equipment. Who joined Phages? Well, look around the room. Phages teachers, do you want to raise your hands? Participant teachers, woohoo. 5 years ago, they made this commitment, and here we sit tonight. All right, so we're very proud of them everywhere, all the way from Baker to more local Helena, Boulder, Anaconda, and Columbus. I've been there like 18 times, but what is our guiding principle? Well, this is back from Dr. Hatful's lab, and this slide I've showed for 20 years, right? Our philosophy is that you don't need to be a physicist to ride a bike. I knew 5-year-olds that can ride bikes, right? Get on and start pedaling. Simple techniques to start. Then later you can ask, how do the gears work, right? Just something simple. Can you push this thing? Oh, look, the liquid came up. Put it over there, push it down. Okay, that's how we start, and then they're asking about the gears. And of course, you all want to know what Phage's outcomes are, and you are going to see those outcomes through the next 2 days. The teachers speaking, students speaking, and at the end we'll wrap up with some of the assessment that Dr. Chris Pavlovich has done for us on Tuesday. And so the outcomes, well, you're just going to see them all for the next 2 days. These posters are ranging from the last 20 years. So many of the people sitting in this room constructed these posters. We went back to the old files and got them printed up. And we're just excited for the phage journeys that you're going to hear about for the next 2 days. And we want to welcome you all, make sure you're comfortable. If you do need anything, just reach out and we will make sure we can solve it if we can. We'll do everything we can to make you happy to be here, because I can't tell you how fast 5, 10, 19 years have gone, but the exclamation points and the bright parts are right here. You're in great company with each other. Okay, I'll give you a sneak peek of the outcomes. K through 12 students can do real meaningful research in their classrooms, and K through 12 teachers can independently deliver meaningful research in their classrooms. So give yourselves a hand. You can. It's fact. All those teachers and students, CFWEP, I could not have done any of this project. None of us could have done this project without our partnership. So I'm so grateful for all the people there. That Raylyn has been by my side since we wrote the grant in 2012 for BRIC. So it's been a little bit of time. But the National Institutes of Health, which means that somebody thinks that this matters, right? At the federal level, giving students access to genuine experiences in science. So we got to thank the taxpayers directly and indirectly. Embry, Montana State University was the lead for the Embry grants that hired me back in 2005. And that funding to get started allowed me to, and also the flexibility of Dr. Rick Douglas, to let me run around the state and do this outreach program that wasn't in my job description exactly. I appreciate that. And his, what's the word for opposite of predecessor? Successor, Dr. Amy Kenzie, has continued her support of the Phage Discovery Program. And we worked with Dr. Jim Driver at the University of Montana in Missoula, and you'll see later that he's been continuing with us to image phages for the last many years. Right. And so we have Dr. Michelle Hardy with us. We're really grateful. It's a very busy time at Montana Tech. They're doing accreditation visits right now, and so we're super grateful that our administrators could find the time to be here. I knew Dr. Hardy from when she was at Montana State when I first joined with Embry, and she has moved on to, she's now our interim provost and executive vice chancellor. She's been our dean, a very supportive dean in the College of Letters, Science, and Professional Studies, soon to be renamed. But welcome, Dr. Hardy. Thank you so much for coming.